Hello students, we will discuss now the operating point and load line. Here we have DC load line and AC load line. So let us find this one. DC load line is a straight line plotted on IC versus VCE, means output current versus output voltage graph. So to calculate VCE and IC graphically, graphically, let us consider an example. Okay, let us consider an example here. RC resistance connected to an NPN transistor, this will be VCE, this will be what? VCC. Now a base resistance is connected like this. So this will be the base resistance, collector resistance. This is grounded. This will be the base voltage. The current flowing through this will be IB. Okay. You can. This is nothing but a circuit given to you. You can even manipulate the circuit as. So this will be the positive, and negative will be what? Grounded here. Okay, so this will be the VCC. Okay, now using this circuit, we can apply KVL in this outer loop. So let us consider this as loop 1. So if you apply KVL in this loop, then what is the currents we can? What is the loop equation we can write here? So this is nothing but the collector loop or output loop, anything you can say. So what we can write here from this loop? Minus VCC plus the current flowing through this part will be IC into RC plus VCE is equal to what? There are no voltage drops here. So this will be equal to 0. Now IC into RC is equal to what we can write here? Minus VCE plus VCC. So this also can also be written as IC is equal to minus 1 by RC times VCE plus VCC by RC. If you let us take this as equation number 1. If you observe this equation 1, this is similar to, we can even compare this with the straight line, passing through some point. Y is equal to mx plus c. What is the value of C? Yes. What is the value of C? What is the value of M? The above equation represents, equation 1 represents a straight line with some slope. What is the slope value we have here? Minus 1 by RC. Minus 1 by RC is a slope, and y-intercept will be What is the y-intercept? Y-intercept value will be what? VCC by RC. So it is also known as DC load line. It is known as DC load line. DC load line. What is y-intercept value? Y-intercept is VCC by RC. That is when x is equal to 0. To obtain y-intercept, x is equal to 0. To obtain x-intercept, put y is equal to 0. X-intercept will be just only VCC. That is when y is equal to 0. So if you plot this in a graph, if you take the graph between, if you plot the graph between IC versus VCE, if you plot the graph between IC versus VCE, so this is the VCE versus IC. Now for a given value of IB, for a given value of IB, the point of intersection of the characteristic curve and the DC load line is known as the operating point. For example, if IC versus VCE, if you draw a straight line, so what is x-intercept? X-intercept means when x is equal, y-intercept means when x is equal to 0, what is the value of y value? Will be VCC by RC. When x is equal to 0, what is the value of y-intercept will be? VCC by RC. When y is equal to 0, what is the value of x-intercept will be? VCC. Okay, if you draw a line here, okay, if you draw a line here, this is the DC load line. This is called DC load line. Okay, hope you understand this point. So at intervals of time, at intervals of these parameters, so the base current will be what? Changing with different intervals. Here it is crossing this DC load line at this operating point. If we increase further, then this will be the IB2. So this is crossing at this point. This will be the IB3. Okay. The operating points are the point of intersection of the characteristic curve and the DC load line. The point of intersection of characteristic curve curves and DC load line is known as operating point. Okay, or operating point, or it is also called as quiescent point. Or Q point. Okay, the coordinates of the operating points are DC values of VCE and IC. So this value will be the coordinates of of the operating point, the coordinates of the operating point are the DC values of VCE and IC. That implies operating point will be between this region, VCE comma IC. So between these only we will be defining the operating point. Okay. So let me give you some important points here. DC load line is also called locus of operating point. Next point is, when BJT used as an amplifier, when BJT is used as an amplifier, operating point is located at exactly middle. Okay, when it is used as an amplifier, it is exactly located at the middle of the load line. To obtain the distortionless output. Okay, I hope this point is clear. We can even solve this by an example. So the example will goes like this. Transistor with emitter resistance, transistor with the collector resistance. Okay, having a divider circuit here. Let us apply the self-bias circuit only. Let us find the operating point for the self-bias circuit. So this will be VCC and this will be the ground. This is also ground. Okay. Now you have to remember here one point here. Find the Q point, operating point. Okay. Now the current flowing through this will be IC. Here also IE. IE and IC both are same here. So you have to remember this is emitter current. Solution will be, you have to first remember that IE is equal to IC. Okay, now apply KVL. Apply KVL means where you have to apply KVL. KVL will be applied in the outer loop. Okay. If you observe this circuit, we can even draw this circuit. This will be plus. Sorry. So this will be plus and minus. Minus is connected to ground. So in this way we can apply KVL here. So this is nothing but VCC. So apply KVL in outer loop. Why outer loop? We have to find the value of IC, no? So for that reason we have to apply KVL in the outer loop. Then what we get here? If we apply KVL in the outer loop, then we get minus VCC plus IC into RC plus what is the value here? We get VCE, collector to emitter, plus VCE plus IC into RE. IC into RE is equal to 0. Then what we get here? IC into RC plus RE plus VCE is equal to minus VCC to the other side will be plus VCC. Then if we simplify this, what we get here? IC is equal to minus 1 by RC plus RE into VCE plus 1 divided by RC plus RE into VCC. If you compare this with the standard form, yes or no? How do we compare this with the standard form? Y is equal to m into x plus c. What is the slope? Slope is nothing but, what is the slope? Slope m is equal to minus 1 by RC plus RE. Okay. Then what is y-intercept? How to find the y-intercept? Put x equal to 0. X equal to 0 means VC is equal to 0. Then what we get here? VCC by RC plus RE will be the y-intercept. The same way x-intercept will be. For finding this, we get VC is equal to 0. For finding the x-intercept, put VCC is equal to 0. For finding y-intercept, we have made x equal to 0. For finding x-intercept, put y is equal to 0. Y is equal to 0 means, what we get here? Simple VCC. Okay. So the graph will be like this. Y-intercept will be VCC by RC plus RE. What is x-intercept? Will be VCC. So this will be the DC load line. I hope this point is clear to everyone. Now we have to find the operating point. Operating point means we have to find the VC comma IC. Okay, we have the value of IC, we also have the value of VCE. Then we can find the value of operating point, where it is lying. If it is exactly lying in the center, then Q will be in active region. Active region means it will be used as an amplifier. If it is lying exactly at this corner, this is cut off. If it is exactly lying here, this is saturation. Hope this point is clear to everyone.